Hi, I'm Quinn Perkins, and this is my individual computer security video presentation. My instructor is Jennifer Grant, and everything here shown is for an educational purpose. Today we move from legacy full tunnel VPN to zero trust network access. The goal of this is to reduce lateral movement, eliminate excess privilege, and lock down your attack surface. Here's the table of contents. I will cover all of these topics, and I will share a unique Cloudflare demo. Let's get started. Legacy full tunnel VPN fails in hybrid work because legacy VPN gives full network access after one login. Users are able to see more than what they need, so attackers are able to move laterally with stolen credentials, and there's no continuous verification. So device health is not checked, and simply put, the castle and moat model breaks in hybrid and cloud environments. So excessive privileges turn breaches into full-on compromises. VPN uses a single gateway and a static tunnel, and authentication only happens once. All traffic backhauls through the hub, and in the context of ZTNA, ZTNA splits control and data. PDP and PA make identity and posture decisions, while PEP enforces access per application. Traffic goes directly to the resource, and identity and device replace the network location. And finally, global points of presence enforce policies everywhere. NIST defines zero trust with 7 core tenets. First, never trust by default. Every request is authenticated. Second, network location means nothing, so internal or external, it's the same rules. Third, per session access. Connecting to app A does not grant access to app B. Fourth, least privilege. You get only what you need. Fifth, continuous monitoring. Sixth, adaptive policies, so change the rules based on risk signals. Seventh, collect as much data as possible about asset state and network behavior, and use that intelligence to improve defenses. This slide is on attribute-based access control, also known as ABAC. Essentially, role-based access control is 2 cores, and with ABAC evaluates user, device, location, time, and resource. Access becomes dynamic. An example is only allow a sales manager on a corporate laptop in office on weekdays. This aligns with least privilege and federal zero trust standards. Just-in-time, also known as JIT, grants admin rights only when needed. Access expires automatically, and it lowers long-term privilege exposure. Attackers can't exploit dormant admin roles, and approval workflows keep it controlled. This cuts credential abuse and privilege escalation. As for device posture, every device must meet security baseline. ZTNA checks the OS level, AV, firewall, disk encryption, and patch status. Non-compliant devices are denied or isolated. Posture scores feed into ABAC rules, and essentially this enforces continuous trust evaluation. As for micro-segmentation, ZTNA isolates every resource behind its own enforcement point. Breaches cannot spread laterally. East to west movement is blocked, and only approved users reach the specific app. This shrinks the attack surface and stops internal pivoting. As for migration plan, the plan is to discover users, devices, and apps, design ABAC, posture, and JIT policies, pilot with a small group and fix issues early, roll out ZTNA linked to your identity provider, expand coverage and retire VPN access gradually, and decommission the VPN once all apps are migrated and validated. Next, I will begin the Cloudflare demo. In this demo, I will show how each application has its own access policy. Device posture gates access. WARP is required for posture checks. Access is identity-based, not network-based. The user experience is seamless because there is no manual VPN connection, and policies update instantly from the dashboard. Today I will be demoing Cloudflare. I'm going to focus on zero trust, but essentially Cloudflare works to protect your site against malicious traffic. Starting here from the account home, as you can see, there are many different options and services that Cloudflare provides. My Zero Trust team name is going to be Quinn Demo. I already have it set up, and for the sake of this demo, I didn't create a public domain, but that is an option down here. And in terms of Zero Trust products, there are a lot of different options, but today I'm going to be focusing mainly on policies. Next up, I'm going to share the Warp device client. I already have it installed, but if you're on Mac, it'll go up here. And for the sake of the demo, when this is disconnected, that means my internet is not private. But I already have it connected because whenever I connect it, it kicks me out of my Teams call up there. But I'm going to move to the preferences, and I'm going to log into Cloudflare Zero Trust. And as I said before, my team name is Quinn Demo, so I'm going to input that, and that will bring me to the sign-in page. Now that I have my access code, I can log in. And as you can see right here it's not my email, this is a system-generated identity realm for my Cloudflare Zero Trust team. But when I sign in, I'm given this option. As you can see, it now says Zero Trust, and my internet is protected. Some of the preferences are different now, as now I have my team name there. And if I want to go back to the previous version of the web client, I had to log out. And next, I'm going to explain another reason why I had to sign in. Under Access and Policies is where you create new policies and rules. Right here, I have one named Allow Yahoo Enrollment. The reason for that is my email address ends with @yahoo.com. So I created a policy that had a rule that stated to include emails ending in yahoo.com. Along with include, there are different types of rules, such as require and exclude. It also offers policy testers, and you use these policies when you're creating your applications, which that is under here. And I have two applications. I have a bookmark and a self-hosted. I'll start with the self-hosted. This here is my self-hosted application. In production, this would connect through a tunnel, but for the sake of the demo, I used demo.local on port 443. But there are different options. You can also do a public host or a private IP address. And next, you add your policies, which, as you've seen before, I have my Yahoo policy. What this essentially means is, on this application, it allows for Yahoo emails. And up here, this is where I'm associated with my email, because I've already logged in and I'm connected with Zero Trust. And there are different settings that I won't go into now, but as you can see, it's a very comprehensive UI. And next I have my bookmark, and in the demo, since I haven't uploaded a public domain, this is what's going to show up in the applications dashboard. But yeah, this is similar to self-hosted. You can configure it. You can set your application name and application URL. And now that I have fully configured my Cloudflare and my Zero Trust and all my policies, what I can do next is I can visit my applications. And like I said before, the only one that's going to show up is my bookmark, and Within the demo, I haven't actually created the application, but essentially this is how Cloudflare works. And if anyone's curious, you can download the client here for Windows and Mac OS. And plans and pricing, they have free, pro, and business. And of course for this demo, I went free. Yeah, I hope the demo was straightforward and informative, and I encourage everyone to check out Cloudflare for themselves. Anyway, let's move on to measuring ZTNA success. When measuring success, one should track lateral movement incidents before and after migration, measure provisioning time from days to minutes, count block policy violations, track device compliance percentages, monitor session reauthentication, and survey user experience to confirm reduced friction. In terms of user experience and admin impact, in VPN uses and requires manual connect, and this causes slower backhaul, and users can see the full network. ZTNA uses a transparent client and connects directly to apps. In VPN uses hub and spoke, complex ACLs, and static configs, while ZTNA uses distributed points of presence, centralized policy, dynamic updates, and full telemetry. Training is minimal, and support tickets drop after the adjustment phase. In conclusion, the traditional virtual private network model grants too much access. One login exposes the entire internal network and makes sideways movement too easy for attackers. Zero Trust Network Access solves this by checking identity, device health, and context on every request. Access is limited to a single application at a time. Each resource sits behind its own enforcement point, so a breach cannot spread across the environment. Traffic goes directly to the application, so the connection is faster and smoother for users. There is no manual connection step, which reduces confusion and support issues. Operations benefit from centralized policy management and real-time updates. Here are my sources. Hope you got something out of the video. Here are my sources. Hope you learned something or at least got. Here are my sources. Hope you liked the video and got something out of it. And I hope my background changes didn't distract or take away from anything. And thank you for watching.